All right. Well, Kyle, if you're ready, I guess we'll probably go ahead and get started.
Mhm.
So yeah, thank you everyone for attending the Multicopter Warehouse introduction to the new L2 here. I am Douglas Bach,
And I'm Whittaker Gramly.
and we are joined with our great friend Kyle Miller at DJI.
Nice to be
All
here with you guys.
right. So without further ado, we'll kind of jump in here. So yeah, if you want to give yourself a quick introduction.
Yeah, so I grew up in Champaign-Urbana, Illinois. Went to Bradley University for computer science. And then I moved out here to Denver about 4 years ago. Worked in solar for a while, designing solar systems. Then I joined up at Multicopter almost 1 year ago now.
Very cool. Yep. And then I am Douglas Bach, so I'm the other survey mapping specialist here at Multicopter Warehouse, covering the West region here. Grew up in Southern Illinois, attended the University of Illinois for 4 years. Got into surveying through the Illinois Department of Transportation for a couple summers while I was in college. Then was employed by a design firm in their survey sector in Tennessee for about a year or so, and came out here, worked for Trimble for a little while doing geospatial technical support, and now I am here with Multicopter. And then Kyle, do you want to give yourself a little bit of a introduction?
Sure. Nice to meet everyone. My name is Kyle Miller. I believe I've done a bio before at Multicopter, so I'll do a very brief one. I've been in the drone industry now for a little while, worked at a couple different hardware and software manufacturers and photogrammetry engines. My experience at DJI is on the geospatial side, so helping out with products that are going to be surveying and mapping focused.
Beautiful, awesome. So yeah, what we're going to go over today is Whit and I will go over a little bit of the M350 airframe, and then that will snowball us into Kyle's section of talking about the brand new LiDAR payload from DJI, the L2. So without further ado, let's talk about the M350 a little bit, or the Matrice 350, as some of you might know it. So this is a medium lift drone, IP55 rated, so it's excellent in a little bit of a downpour and some dusty conditions. I've had several real life customers tell me that they've had their M350 out in pretty torrential downpours and it's handled it. So it's good to have real testimonial, and I'm sure Kyle's not surprised to hear that. Excellent wind resistance. We say up to 27 miles per hour, but the same customers are telling me they're flying them in higher conditions, but know that it is rated to about 27 miles per hour. And then as far as the M350 goes, upgraded from the M300, we had a brand new battery system, brand new controller, a nice big screen, which we'll talk about here in a minute, and excellent RTK positioning, adding some extra constellations in there. But great flight time, great scalability if you're trying to do survey, if you're trying to do public safety or an inspection work. You can throw a P1 on there for your photogrammetry, LiDAR payloads, as we'll get into. And then, as I said before, all the public safety and inspection tools you could ever want. So really excited that we've been blessed with the M350 here, and yeah, it's just overall a 10 out of 10 airframe, and we're lucky to have it.
One of the big upgrades when they switched to the M350 is the controller. I really think this controller alone is a great reason to upgrade if you're looking at getting a new drone. With the screen, they've improved the screen size, but they've also made it waterproof and dustproof. So I've actually been out flying the M300 before and had to wrap up a mission early because of rain. It's no longer the case here with the M350 with the waterproof controller. Another cool thing they did with it is that pretty much everything that came out with the M350 is backwards compatible, which I'm a pretty big fan of. So you can get the upgraded controller for your older drone platforms as well.
Absolutely.
And another one of the biggest upgrades that I was excited to see was the new battery charging station system. They basically doubled the amount of cycles you can get out of the batteries by making a couple tweaks to the charger and to the batteries themselves. So now you can actually charge it up to 50% for long-term storage, or 100% for if you're flying soon and need a fully full battery.
Yeah.
And the batteries are also backwards compatible with the M350.
Cool. So Kyle, we'll kick it over to you. Would you like us to make you the presenter so you can kind of go at your own pace here?
Yeah, I'll just tell you to do next slide if you want to. Let's not make it too complicated. But I'm glad that you guys were able to kind of run over the Matrice 350 line. I mean, ultimately, there's some smaller improvements on the 300 up to the 350. One of them being coming with the RC Plus, but then also being backwards compatible. So that was nice. But yeah, the drone that really is that multi-tool, it can lift up to 2.7 kilograms. You're seeing payload SDK. And so you're seeing a wide variety of sensors on it, whether it's a full frame photogrammetry sensor, or you're looking at LiDAR like this, or some other specialty use cases. That Matrice 350 is really the kind of the bread and butter. But what do we fly that drone, and what do we hang underneath it? That would be the new L2 that we were able to launch last month. So really excited about this new product, something that I've been able to work with fairly extensively before launch. And we've got a couple of use cases that we can definitely talk about. So yeah, let's talk about some of the improvements of the L2 over the L1 and some of its other competitors. Cool. So getting started, many of you may have seen a timeline of DJI before. This one is very specific to the geospatial side. So in 2017 was the very first drone that we had RTK enabled. It was mainly for positional flight. But we are able to have very accurate flight. Then you look into 2018 with the Phantom 4 RTK releasing. We know that there's a lot of those out in the wild, just being a very small, easy to use, affordable platform that's truly tagging the imagery with RTK. There is our first real, I would say, survey tool. It is a drone, but it's really ends up being another piece of survey equipment. So that's kind of where we got on the geospatial side. 2019, we needed to be able to process that data, so we launched DJI Terra. And then over the past couple of years, have had some really big improvements. So the Matrice 300 over the 200. For those of you that have flown both platforms, I think you understand the major improvements there, as well as the payloads that it came out with. So P1 and L1 for surveying, big improvements over the X5, X7, and also the affordability of the L1. And then 2022, released the Mavic 3 Enterprise, our affordable solution for surveying with photogrammetry. And then 2023, a nice upgrade to the 350. So how do we finish out 2023 with on the geospatial side as far as product launches? And that would be with the L2. So I think on the next slide, yeah, got a quick little video just teasing that L2, looking very similar to the L1, just a little bit wider. But it's a product that we are very excited about because there's a lot of changes on the inside. So on the next slide, it should go through a breakdown, just an overall breakdown, and there's a lot of material there of what the major improvements are and the 6 factors we're going to be focusing on today. So with the L2, you're seeing a higher level of precision compared to the L1. So we're seeing a horizontal accuracy of 5 centimeters, vertical accuracy of 4 centimeters, and that's flying all the way up at 150 feet. And so if you are flying lower, you can even gain potentially higher levels of accuracy. Exceptional efficiency. We're going to show you a little bit later if we were comparing apples to apples as far as accuracy and points on the ground, L1 to L2, we're covering about 5 times as much with the L2 and maintaining the same outputs. So a lot more efficient, better enhanced workflow that you're seeing on the controller, that is the LiDAR point cloud being built real time, so you can get that diagnostic feedback. Also superior penetration. So we're seeing, rather than on I know I keep comparing it to the L1, but with the L2 having 5 returns, 240,000 points across all 5 returns, it's like 3 times as many points going out of that laser sensor, and also getting deeper penetration with that 4th and 5th return. Improved detection range. So I know in the United States, we don't typically worry too much about it since we're flying below 400 feet typically. But depending on what the surface is, it can definitely help out. So improved detection range, and then the integrated visual camera. It's just a nice upgrade, which is basically going from the L1 having the Phantom 4 Pro camera to the L2 having the Mavic 3 Enterprise camera. We'll talk about the benefits of what that is in just a moment. But with this one, moving on to the elevated precision, There's a number of different factors that go into accuracy. It can be the IMU or the INS, the inertial navigation system, and understanding how accurate it is in measuring those small movements of the LiDAR sensor, as well as the LiDAR module itself. How big is that laser, how big is the beam divergence that we're seeing on that laser module, as well as how large is that spot that the laser is actually capturing. So between those two, we're seeing great improvements. You compare the L1 to the L2 here, we're gaining slightly better or a bit better accuracy. Horizontal 5 centimeters, vertical 4 centimeters, that's flying at 150 meters. L1 getting 10 centimeters horizontal, 5 centimeters vertical. That's also flying 3 times lower. So the efficiency goes way down there. So we're thinking improvements on efficiency when we're comparing apples to apples with accuracy, big gains.
Absolutely.
Yeah, and I apologize there. The next one, talking about the actual LiDAR module and how it's able to capture more than the 3 returns on the L1. So let me put you on the spot here a little bit, guys. So when we're thinking of superior penetration, what are the typical industries that would be benefiting from having 5 returns or having deeper penetration?
Absolutely. Yeah. I mean, forestry is obviously a big one. You know, cutting through that vegetation that, you know, people in the forestry industry have to deal with is going to be, I mean, that's their bread and butter right there. So more returns obviously going to be big for them. And I mean, would you say construction width is going to be another big one?
Yeah, anytime you're trying to get a topo of a site that's not cleared out, a better penetrating LiDAR is going to be a big help, as well as I really like the archaeological applications of a LiDAR system, being able to detect foundations of old buildings even through a forest canopy.
Yeah, exactly. Nail on the head. It's where you have a lot of that vegetation and you're trying to be able to get as many points as you can to find the little gaps through the canopy and hit the ground. And so if you're trying to build a good digital terrain model and you've got fairly dense vegetation, being able to have 5 returns is definitely really valuable. You can also see there's kind of a chart there, or a little diagram showing you the beam divergence size. So overall, we're having about a 5 times smaller beam divergence on the L2, which that essentially relates back to accuracy. And if we're looking at curb and cutter, and we're looking at how tight that curb is, having a much smaller beam divergence on that LiDAR module helps make it really, really tight rather than kind of that traditional LiDAR where it's a bit curved and evening it out. So yeah, well, much better. We talked about an improved INS with accuracy. Now we're talking about the definitely improved laser module here.
Beautiful.
Yeah, and now we're talking about being able to build that DTM. So we can see here, there's a little bit of a diagram. Sorry, let me scroll out a little bit. Comparing the L2 to the L1, it was one flight, there was a flight flown over the exact same location. You can see that we do have about the same amount of points hitting the ground in the non-vegetated areas. So what you're looking at right now is a data set processed with DJI Terra. All of those orange points, those are all going to be points that we have classified as ground points. And we have removed the filter of vegetation, so now we're just seeing ground points. So anywhere that's dark is going to be more sparse point or digital terrain model, or the amount of points that are actually hitting the ground. And so as you can see here with the L2 getting so many more points in those dark areas where there's going to be canopy, 92 points per square meter compared to 36. And if you're looking at the actual comparison of the map, they're getting about the same amount of points, which means the L2 flew higher and faster on this mission, and then also got more points in the canopy. So big, big improvements there with creating digital terrain models.
Yeah, it's a thing of beauty, Kyle.
It sure is. And being able to capture more area by maintaining the same amount of accuracy that we're looking at with the L1. Now we're looking at, with the L1 single flight, about 0.5 square kilometers, where we're trying to maintain that same 4 centimeter horizontal and 5 centimeter vertical. And now you're looking at the L2 capturing 5 times as much data. So overall, efficiency-wise, that's going to be a big one. And then also another aspect, Doug, have you guys, when you're flying the L1 and you're turning the drone on, you're getting everything ready, what's the most painful experience about the L1 before launch? I think you guys already. Yep, that warm-up period. Yep, it's sometimes it's 5 minimum minutes. It sometimes can take a little bit longer. It is a process. I know that even on the M300 and the 350 flying the L1, you can do the hotspot battery. But if you do have any sort of technical issues where you got to reboot the drone, you got to have that drone just sit on the ground and do the IMU calibration before you launch. And the big improvement here is the L2 does not require an IMU calibration when it first turns on. So much like photogrammetry, you plan your mission, you turn your drone on, and you just hit go, and it's ready to go. So helping out as far as the efficiency's sake on all sides.
Yeah, taking our demo unit out of the box and activating it and going up in the sky, it was like, we couldn't believe it. It was like, oh, well, here we go. Big improvement from DJI.
Yeah. I guess the one last aspect, if you want to go back, I think we may have a slide on it later, but I want to make sure to touch on it, the simultaneous data collection, the photogrammetry and point cloud. We do have a slide on the Mavic 3 Enterprise camera, so we'll talk there, but there are some nice efficiency improvements on capturing that imagery at 0.7 seconds compared to 2 seconds with the old sensor. So sorry about that, if you want to keep going. Enhanced user experience. What was your guys' experience, even with the L1, when you first started flying it and you saw that live point cloud being built in real time? Pretty cool to understand before you even leave the job site, kind of that data acquisition.
Yeah, absolutely. It's I mean, something as like an end user, I mean, it's hard to beat that, you know, when you're out in the field.
Yeah, and there's a lot of solutions now where you're basically taking a drone and you're taking a LiDAR module, you're strapping the two together. There's really no output from the LiDAR module, and so you really don't know if you're getting high quality data, if it's capturing correctly, and you're getting significant amount of overlap until you get back to the office and you start processing that data. Whereas now, with the enhanced user experience, you're getting some of that, you're getting some of that readout real time. Then we can make some decisions. Are we getting significant amount of side lap? Are the trees that we're capturing taller than we originally thought, and we need to have a higher standoff distance or more side overlap? So you're getting all of that real time. Also, every single time that the drone comes and returns home from a mission, it's going to give you a fieldwork quality report, so you can make sure that was that flight successful? Did we make sure to capture good data? And then the point cloud library. So not just viewing the data real time, but you're also having that stored to the RC Plus, so that you're going to be able to go back and see any of those point clouds on the actual controller.
Awesome.
Cool. And then point cloud processing. So we know that we're capturing a lot of data with this L2. What do we then do with it? And what is the next step? Because it's one thing to just come out with hardware, but it's another thing to come out with a complete solution. So DJI Terra now supports, with the newest firmware, the newest software release, processing of L2 data. Also, we wanted to make sure that it does not cost. We're not looking to nickel and dime people for Terra when they've already made the big purchase on the L2. And so when you buy an L2, you do get a license of DJI Terra for processing those LiDAR point clouds for free. And then you're going to be able to export out those LAS files. And then if you need to use them in third-party platforms, be TerraSolid, Virtual Surveyor, whatever that would be, you can export it out as well. So being able to just give you DJI Terra to make sure that you get the outputs for free is something that we felt like we really needed to do, rather than trying to make it more of a burden to utilize the platform.
Yep, absolutely. Yeah, an improved LiDAR module and free software. I don't know how you could beat that. So.
Yeah, I would say the same. And the L2 coming out at pretty much the same price point of the L1, with the amount of efficiencies and improvements we're seeing over the L1 is a bit mind-blowing in my opinion. Some of the other updates that we've actually done to the software, the first one being processing algorithm upgrades. So you can see when you have, when you process the Terra data set, the exact same data set with point cloud optimization turned on and turned off. It is a little bit like strip alignment, but we do have a couple other features in point cloud optimization. But you can see there between one pass to another, you're having a really clean elevation profile and you're not seeing mismatched lines that are going below the actual horizon. And then we also have a tool that's smoothing the point cloud out. And so if you're seeing really like fuzzy or noisy elevation profiles that you're seeing here, by utilizing the smooth point cloud feature, we're now about 3 times as narrow of a point cloud. So if you're looking at something like power lines, or if you're looking to just get a really tight digital terrain model elevation profile, apologies there. But being able to build that with a lot less noise, we do really recommend utilizing that smooth point cloud function.
Beautiful.
And then some other features here. We did just release a point cloud classification tool. We're classifying right now between vegetation and non-vegetation. So you can see the photo in the upper left-hand corner, all of that orange area like before, that is going to be what we have determined non-vegetation, so the ground, and then white is going to be all of the vegetation on top of it. So you can easily remove that vegetation if needed to. Moving down to the lower left-hand corner, we can create that digital elevation model. So we're exporting out DEMs as well. We can also, coming in the next update of Terra, be able to utilize the point cloud profile analysis. So you're going to be able to drag 2 points on a line, and then you can easily see the elevation profile, start measuring the tree canopies, even start understanding how many trees are in that measurement. A lot of tools have started utilizing this, and we want to make sure that Terra could also do the profile analysis. And then a point cloud quality report. So when you're done processing that data, you're going to get a report making sure that you understand what the quality of the data collection and the quality of the data processing was.
Beautiful.
And let's dive, now that we've talked a lot of specs about hardware, let's actually talk about how we've gotten the L2 out on job sites and started utilizing them over the past couple months.
My favorite part.
Yeah. The first one being Powerline digitization. So you can see the difference. We keep comparing the L1 to the L2, but that was one of the biggest frustrations, I would say. Maybe not frustrations, but just the limitations of the L1 having fairly noisy point clouds, especially over very thin structures like power lines. I should say noisier, I shouldn't say fairly noisy, but we were able to tighten that in quite a bit with the L2. Also, you can see the difference between the photo on the L1 and the L2. The very bottom lines we weren't able to capture with the L1, but we are actually getting points on the third set of lines down. So we are able to start understanding line sag, distance, and if there's going to be any vegetation encroachment, getting close to those lines. If you want to go to the next, well, actually, let's go to we'll go through the overview. It was captured in Indonesia. It was flown at 15 meters per second. So that's pretty much as fast as the drone is going to be flying at any point. So efficiency wise, it's going as fast as it can. We didn't slow it down to try to make this pretty. And the L1 was actually flown at 7 meters per second. So we flew it twice as fast and still got a much cleaner point cloud out. A straight nadir gimbal angle, a dual return setting, and then a flight height of 100 meters, which is pretty standard when you get into power lines.
Beautiful. Yeah, that's going to be very big for surveyors and anyone in the industry here. I mean, that efficiency is crazy. So.
Yeah, and one of the crazier things about efficiency is if you look at the actual right-hand side, it's kind of that from a much higher angle view. We processed this data set with a single pass. So the drone didn't even go down and then back and then down and then back again, or how many other passes. It literally just flew from one end to the other end, and the swath was captured this wide, and we're still seeing really high accurate data. And so crazy thing, just one swath down, being able to go and capture and build such a clean point cloud. And then also on the left-hand side, the actual cables connected to the transmission tower and connected back to those other tables, so those standoff cables, we are able to also start getting points on there and build a point cloud from it.
Terrific.
Yeah, point clouds, or not point clouds, power lines. Definitely one of those main use cases when it comes to LiDAR. There's really no great ability of doing it with photogrammetry purely, just being able to model out a power line. So LiDAR, it makes sense. And then the L2 just cleaning up the noise a bit and getting so many more points on those lines. It's going to be a really good tool for the job. Earthwork measurement on a highway construction site. I'd say this is about the most low-hanging fruit. Construction being one of the biggest industries that's adopting LiDAR. Why? Because we're trying to build a digital terrain model. We're just trying to build as clean of an elevation model with no vegetation on it as possible so that we can start measuring cut, fill, stockpile analysis, things like that. So you can see the ground points with all the vegetation removed off of them in the bottom left. So there's no white points. From there, they were able to build a contour lines from the digital terrain model. And so I think they set them at 1 meter resolution contour lines, or maybe those are just 1 foot contour lines. But overall, being able to build that contour, something that's a lot of customers, I would say, come to as a need. Like, when we ask them, what are you looking to get out of drones? It's making a contour map, making a digital terrain model. So building it from there, and then building the actual cut, fill, volume calculation to understand progress of that construction site. So being able to routinely fly it and understand how much more cut do we need to take off the top until we're actually at grade.
Yep.
And overall, the reason why we brought up this use case is mainly about accuracy. The L1 could technically do this same use case, but overall with the L2 being able to fly higher, being able to fly faster, and still maintaining the same, if not better accuracy, that was just a lot of the improvements to the L2. So the L1, you can see the cut and the fill volume and what the actual error is of that pile. And then the L2 getting much higher accuracy cut and fill when we're talking about the actual construction site there. So a cut of 99.9% accuracy and a fill of more than 95% accuracy. So pretty good overall.
Pretty terrific. Yep.
In the last one, this was one that I was actually able to help out on quite a bit, was historical documentation down in the jungles of Guatemala. So you can see in the lower right-hand corner, we're on some actual Mayan ruins, or there's a pyramid that has already been discovered. We had to hike up to the very top of it to be able to launch and maintain connectivity, because we're not anywhere close to a base station for utilizing PPK, and the jungle canopy is so incredibly dense. It's some of the most dense in the world, that your connectivity for RTK is not going to be able to maintain if you're on just the ground floor below the vegetation, and also your video coverage. So whatever you're going to be, the drone and the controller talking to each other, it would cut out very bad. So we hiked to the very top, and we were able to launch there and fly significant amount of data. We were looking at I'm forgetting on the actual square kilometers that we were able to capture, but I believe it was around 15 to 20 square kilometers within just this very short project. So overall, we were able to utilize 4 different Matrice 350s at the same time. 3 of them running the L1, and then 1 of them running the L2, and then processing that in DJI Terra. 2 big full days of capture with 10 hours a day for this specific site. And then we were also flying fairly high, so 140 meters AGL, just because we have really good, even improved reflectivity distance, as well as 12 meters per second, so we're flying fairly fast, 5 returns, non-repetitive scan mode, and then 70% side lap. The really interesting story about this use case was the Guatemalan government was actually contracted to go, or they signed a contract for a private company to go out and capture all of the jungles to help try to find some of these Mayan ruins, some of the pyramids and the causeways, the highways. And they got a little over halfway done, close to 60% done, and the manned aircraft actually crashed. And they lost the aircraft, they lost the payload, they lost all the data that had been captured recently. And so there is a significant amount of data that still needed to be captured, and that's where we were able to patch it in utilizing the drones. And on the next slide, you can see that we battled some of the conditions. We had very long distance missions from where we were since we had to maintain connectivity. But that's the strength of the Matrice 350, being able to fly, 40, I think it's around 40 minutes to 42 minutes with the L2, being able to fly, multiple kilometers away and then start the mission and start capturing. It was also very hot and very humid. We had no real power or air conditioning to be able to cool down these batteries. And so even with the extreme environments, both the Matrice 350 and the battery station and the controller, the RC Plus, all operated exceptionally, and we really didn't have any downtime, and we really didn't have any issues. So this is just going to say of overall the quality of build of DJI enterprise products for getting on these job sites where it just needs to work.
Yep, absolutely. Love to hear it. Real world experience.
Yep, exactly. And this was some of the data output that we were able to generate. So, I mean, that is some absolutely incredibly dense jungle there, where they're on the canopy floor, like it is, even at 12 o'clock at lunchtime, it feels pretty dark underneath that tree canopy. The manned aircraft, obviously flying higher and faster, covering a little bit larger swath area. They're hitting about 40 to 50 points per square meter overall, and only about 2 to 3 points are actually hitting the ground. So not building a dense enough digital terrain model. The L1, while getting much more points out, a much denser point cloud at 250 points per square meter, still only 2 to 5 points of those are actually hitting the ground because we only have triple return, we have less points going out of the payload, and still just wasn't able to penetrate that vegetation. And then the L2, we're capturing 600 points per square meter, flying with the same characteristics as the L1, but since we're getting 3 times as many points out, we're getting a much more dense point cloud. But here's the real kicker. We really finally improved the actual digital terrain model point density, and now we're looking at 40 to 50 points per square meter actually hitting the ground. So now we can finally build a dense enough point cloud where we can start looking at some of these artifacts.
Yeah,
are there any
pretty incredible.
Yeah, are there any other use cases, Doug, that you guys have started really seeing upticks of LiDAR other than historical documentation or stockpile analysis or Powerline?
Yeah, I mean, I'm trying to think here. I mean, I think a lot of like land developers are using it, obviously, like you said, Kyle, to build those digital terrain models. And if they have these, 50, 60, 80 acre plots of land, or how it gets out here in the West, people can own a lot of land in a little bit of time. So trying to capture all that amount of data without having to go conventional, I think a lot of people are starting to trend that way. So any of these big surveyors or these big land developers, I think, are really starting to trend towards LiDAR.
And especially people who historically were leaning more towards photogrammetry. We've seen the cost of LiDAR come down so much. I think people who were doing photogrammetry before are adopting LiDAR more and more, just because the price is pretty much comparable at this point.
Yeah, that's a really good point, Whit. When you're comparing the Matrice 350 and the P1 or the L2, price-wise, you're looking about the same difference, but now you're definitely getting different outputs in something that people have been trying to fill the gap with photogrammetry, but just haven't been as successful because photogrammetry shouldn't be used. And like those use cases that you mentioned, Doug, a lot of that pre-bid, we want to understand before we actually break ground, or even if we bid on that job site, we need to be able to understand the topographical map so we understand how much dirt needs to be moved, and all of them is dollars. And so definitely good points.
Beautiful. Yeah, so that kind of brings us to the end of the presentation. Kyle, do you have anything else you wanted to add before we got into any of the questions?
I think that's it. I did miss actually 2 different specifications. I hate to keep rambling, but I just want to also hit on efficiency. That once again, that Mavic 3 Enterprise sensor being 20 megapixels, but now it's a 4/3 inch compared to a 1 inch. And the biggest thing here is we're capturing at 0.7 seconds instead of 2 seconds. So no longer are we going to have to fly slower with the LiDAR sensor to make sure that our photogrammetry, our imagery is captured fast enough. So improvement there, as well as IMU or INS improvements. So we don't have to wait on the ground when the drone first gets booted up, but also when the drone was doing the back and forth with the IMU calibrations during flight, we improved that from 100 seconds now to 200 seconds. So just keep improving that efficiency.
Beautiful. Well, I love it. Yeah. So I guess we got a couple of questions here. So one question was regarding the L2. Go figure. We're being asked about the availability and the price here at Multicopter. So for those interested in purchasing the L2, now that Kyle has given all the beautiful specs and the use cases, we're looking at probably about 2 weeks before we've got for sale units in. We do have a demo unit in the store. So if you do live here in the Denver metropolitan area or anywhere here in the nearby surrounding cities and you want to come by, we do have the demo. But we should have units available for purchase here within about 2 weeks. And we're looking at a price tag of about $12,430 on that. So looking good there. And then Whit, do you want to address this L1 question about our availability there?
Yeah, actually, we do have about 5 more L1s available at a pretty good discount for people who are looking to get into LiDAR, but wanted to get in a little bit under, save a little bit of money there. Kyle, we got a couple questions for you, actually.
Sure.
Someone asked, can you discuss LiDAR for vertical building tower modeling?
Sure, that's a good question. I would say it's a bit more niche. Not as many people are utilizing LiDAR for building reconstruction, but the big aspects is the L2 is gimbalized, and so unlike many other payloads, LiDAR payloads, you're going to be able to actually just gimbal up. You can write waypoint missions and to the Matrice 350, and so if you wanted to do a facade mission, you can write waypoint missions and have it automatically fly. If you want to do autonomous capture, you can if you want to. Also capture the L2 data completely manually. It will be up to you to do the INS calibrations every 200 seconds, so you won't need to make sure to keep up on that. There's a button on the left-hand side to be able to do that, but it should process just like any other LiDAR data set. It's just making sure. The biggest thing is then mission planning and mission data capture.
Cool. Let's see. We got another question. Someone said that is an incredible data set, the one of those Mayan ruins. They're asking, where else might you need such dense point clouds? I think you might have touched on this a little bit already.
Yeah, I would say most things that's going to be either forestry or just building a digital terrain model with any sort of vegetation around. So Powerline encroachment, that can be one where you have really dense vegetation on the side where you need to be able to model that fairly well. Forestry, they are looking for a little bit higher level of analysis, or analytics. So you're looking at tree crown size, you're looking at tree counting, biomass estimations, things like that. So I would say generally it's going to be on the forestry side that you would need that dense of a point cloud.
And then we have one more question for now. If you guys have more questions, feel free to put them over here on the right. But the last one for now is, will post-processing classification of the L2 data enable distinguishing power cables from the poles and towers supporting the cables?
Great question. As of right now, our classification is only 2, so ground and vegetation. There's no real way within Terra to be able to classify manually your own points and add in different types of classifications, but there are tools to be able to do it. So if you're looking at something like Terra Solid, that'd probably be the best tool to start really dissecting.
Excellent. Thank you, Kyle. That is all the questions we have for now.
Cool.
Perfect.
Awesome. Well, yeah, well, thank you everyone for attending here. We appreciate you taking time out of your busy days. And Kyle, I appreciate you joining us. I know you've had a hectic schedule, and we appreciate having the best in the business here talk with us. So it means a lot to us having you as a resource. So hopefully everyone else feels the same way.
Thanks a bunch, guys. It's been a pleasure being on another Multicopter Warehouse call. I'm sure I'll be on another one at some point very soon. But if anyone has any questions, feel free to reach out to the Multicopter Warehouse team. And if it's technical, I'm also able to help out. We'll just loop these guys in. So thank you guys for hosting.
You got it, Kyle. Thank you, buddy. And with that, I guess we'll go ahead and end the broadcast. So thanks everyone for attending.
Thank you, guys. Take care.
Everyone have a good day.
You too. Bye-bye.